Is problem 1 on practice exam 8 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. We have a half moon window. It's a half a circle on the top, and then there's a rectangle on the bottom. The rectangle on the bottom has height h and width w. The diameter of the semicircle is w, which means it has a radius of half w. So the area of this window is WH, which is the rectangle at the bottom, and then it's 1/8 pi w squared because that's the diameter. That's the area. What's the difference equation for the area of the window? When h changes and w is held constant, so we're holding w constant and we're changing h. The normal equation is that's given. The difference equation for constant w, we're not going to change w. There's no delta w, only a delta h. So we're changing h right here, and we have a change in area as a result. So I subtract the area A from both sides, which is this thing. So WH plus 1/8 pi W squared. We're only left with a W delta H. There it is. Now, this should make perfect sense to you. If you keep W the same and you change the area, the height, the increase in the area is the width, W, times delta H, right? You're going to add another rectangle down here. You're not changing the width, so it's W delta H. Makes sense. Part B. What's the difference equation when W changes and H is held constant? So we keep this, but then we make it wider, which means the circle is going to get taller as well. So the normal equation is WH plus 1/8 pi W squared. For constant H, we leave H the same and we change W. So now we got a square. This is a lot more complicated than just H. We multiply that out, subtracting A from both sides. Can we find the A? The A is WH plus 1/8 pi W squared. This plus that is A. So we get rid of that, and we have this. There's delta A when W changes and H does not change. Part C. Both H and W change. So this is even going to be more messy. So here's the normal equation. We're going to change both W and H, and we get this. So now we have to multiply this out and square that. And then we get this. And subtract A, which is this, and that right there. So that is a difference term. And you should be able to pick out the linear and the nonlinear terms. So D, we have two half-moon windows. One is a width of 3 feet and a height of 4 feet. The other has a width of 5 feet and a height of 7.5 feet. Subtract these two areas. We're going to use the normal equation to get delta A. So there's a good idea to draw them. We're just going to use the normal equation twice. 15.5343 square feet for the small window. The big window is 47.3175. Difference is 31.78. That's the answer to part D. Part E is use the difference equation we derived and compare it with the result we got with the normal equation. So here's the difference equation. W is 3 feet. Delta W is 2 feet. We're going to 5 feet. In H, we went from 4 to 7.5. So delta H is 3.5 feet. We stick in all the numbers. You probably should take some time to make sure all those are right. All those make sense. Doing the math slowly and putting it all together, and we get 31.78, which is exactly what we had last time. Should all make sense.